Hey, welcome to the Explainer. All right, today we're jumping into one of the absolute biggest quests in all of science, the search for a single, unified theory of everything. You know, for decades, physicists have been dreaming of that one elegant equation that could describe the entire cosmos. But here's a wild thought. What if that entire quest is pointed in the wrong direction?
So that leads us right to this question. And honestly, it challenges the very foundation of modern physics. For almost 100 years now, the big assumption has been that we must combine general relativity and quantum mechanics. But this forces us to stop and ask something way more basic. Why? Have we been so obsessed with how to unite them that we never stop to ask if we should be doing it at all?
Okay, so to really get what's going on, you gotta meet the two main players here. On one side, you've got general relativity. That's Einstein's masterpiece for all the big stuff. Planets, galaxies, the smooth, continuous fabric of space-time. Then on the other side, you've got quantum mechanics, the totally wild theory of the small stuff, particles, atoms, all the fundamental forces. It's all about probabilities and weird jumps. It's quantized. Reality at that level is like a series of snapshots, not a smooth movie. And yeah, these two descriptions of our universe, they do not play well together, at all.
Right, so that huge conflict is what's been driving this whole search for a unified theory. But that brings us to our first big idea here, where we really have to ask, what if the goal itself is the problem?
So for years, the leading candidate to solve this puzzle has been string theory. It's just so mathematically beautiful, and as our source material points out, it's often called the best way to bring quantum mechanics and general relativity together. The whole idea is that, deep down, everything is made of these teeny, tiny vibrating strings, and depending on how they vibrate, you get all the different particles and forces we see. I mean, it's a truly beautiful idea, right?
But, and this is a big but, what if that whole starting point is just wrong? Our source puts it pretty bluntly. If the goal of combining quantum mechanics and general relativity isn't the right one, then string theory just isn't the right path. Basically, what this is saying is that string theory, which was built from the ground up to produce general relativity, might just be this brilliant, elegant solution to completely the wrong problem.
So the real potential issue here with string theory might not be its math or its complexity. It's the goal, its entire purpose. It was built to solve a problem, that massive divide between the big and the small that we just assumed was there and needed to be fixed. But what if that very assumption is where we took a wrong turn?
Okay, so this whole thing raises an even deeper problem, a more practical one, which gets us to our next section, the verification problem. I mean, even if you come up with some grand theory of everything, how on earth do you prove it's the right one?
In old school science, it's pretty simple. You have a theory, you run an experiment, you see if it works. But when you get down to the quantum level, things get really, really fuzzy. How can you really verify something when the universe itself seems so uncertain? From a quantum point of view, the very act of setting up an experiment means you're already making assumptions about how the universe works, and those assumptions could be the flawed part.
Look, experimental verification, that's the gold standard in science, right? But it kind of depends on being able to isolate a system to test it. And quantum mechanics basically says that's impossible. Deep down, the person watching and the thing being watched are all tangled up together. So how can you possibly design the perfect test if the universe itself won't sit still long enough for you to even be sure you're asking the right question in the first place?
Okay, so if the goal is shaky and proving anything is a total nightmare, where does that even leave us? Well, maybe, as we're about to see, the answer is to think about it differently, to create a framework not for the universe itself, but for us, for humans. It's a huge shift in focus from the cosmos out there to the observer in here.
And this question, man, it just reframes the entire scientific project. Who is asking these questions? The universe isn't asking what particles are made of. We are. Human beings with our particular brains and our particular tools are the ones trying to figure all this out. And this changes everything. It suggests that maybe science isn't this totally detached process of finding some absolute capital T truth. It's more like a human conversation with the universe. The theories we come up with are shaped by the kinds of questions we're able to ask. It's like the observer isn't just watching the game. The observer is helping write the rules.
And this brings us all the way back to string theory.
but in a totally new light. As our source suggests, even if it's not the final theory of everything, it could still be something incredibly important, a framework for human perspectives.
So what does that actually mean? Let's just break it down. Okay, so step 1, we got to accept that maybe a theory isn't the final truth. Step 2, instead, think of it like a tool, a really powerful one. So, what does this tool do? Step 3, it shapes how we see everything. And maybe most importantly, it gives us brand new ways to ask questions. It's not the final destination, it's a new kind of vehicle for exploration.
You know, we started this whole journey looking for that one single theory to explain all of reality. And we're ending up with a totally different, and maybe, just maybe, a much more interesting question. If a theory like string theory pushes the boundaries of math, if it inspires new ways of thinking, if it gives us a whole new language to talk about the universe, even if we can never truly prove it, can it still be profoundly useful? That's the idea we'll leave you with. Thanks for watching The Explain.